Coordinate geometry 1. We are going to consider the Cartesian coordinates. Now the word Cartesian is from the name of the famous French mathematician and scientist René Descartes. Here is our Cartesian coordinate system, also known as the rectangular coordinate system. Now we have the x-axis to be the horizontal axis and the y-axis to be the vertical. Then the O, that's the origin where the two axes intersect. Now if you have a point A, an ordered pair of course, with the first coordinate being the x coordinate, also known as the abscissa, then the second coordinate being the y coordinate, also known as the ordinate. Now before we proceed further, let's take some activity. So here you are just plotting the points AB. So the point A has coordinates 2, 3. Then B has coordinates 8, 7. Then we can connect the two with a line segment. So line segment AB. Now we can divide this line into two equal parts. So here is the midpoint of the two lines, C. So what do you think are the coordinates of C? So the coordinates of C are coordinates of C are 5 and 5. Now, how do we calculate this midpoint in general? So we are going to look at a general formula that can help us calculate for midpoints of 2 points. Midpoint of 2 points. Now, here is our y and x axis. Then we have our point x1 and y1. Then we also have x2 and y2. Now connecting these two lines, or connecting these 2 points, we have a line segment AB. Now from A to B, or moving from A to B, we move horizontally and vertically. And these two lines are perpendicular to each other. Now we seek to find the midpoint of the 2 points AB, which are x of m and y of m. And the distance from here to here will give us x of m minus x of 1. Then this distance will give us x2 minus x of m. Then also this distance will be y of m minus y1. Then here will be y2 minus y of m. So we seek to find the coordinate x of m and y of m in terms of x1, y1, and x2, y2. So we know that these two lines are equal because this is dividing this into two equal parts, and the distance from here to here is same as the distance from here to here. Therefore, we have x of m minus x of 1 equal x2 minus xm. So we simplify this by grouping like terms. Solving for x of m, we get the x coordinate of the midpoint be x1 plus x2 over 2. Then the y coordinates of the midpoint will be given by y1 plus y2 over 2. Now let's take examples That will let us know how to use this formula to find the midpoints of 2 points. So this is our first example. We are finding the midpoints of the 2.0 and 4. So you know that the midpoint, the x-coordinate of the midpoint is given by x of m, which is x1 plus x2 over 2, and so this will give us 0 plus 3 over 2, which is the same as 3 over 2 or one whole number 1 over 2. Then also we have our x of m, our y of m, which is equal to y1 plus y2 all over 2, and this will give us our y1 is 4 plus minus 2 all over 2, and this will give us minus, that is positive 2 over 2, which is equal to 1. So our midpoint is given by x of m and y of m, which is one whole number 1 over 2 comma 1. Now the b part. So let's sketch the line segment A, B, then we have the midpoints M, which is 4, negative 2. Now we know the coordinates of A to be 1, 5. Now B is what we don't know and we are looking for it, so let's denote it by AB. Then we know that x of m is supposed to be equal to x1 plus x2 over 2. Then our x of m now, which is 4, is now equal to x1, which is 1. So 1 plus a over 2. So we have 8 b equal to 1 plus a. So we have our a to be equal to 7. Then also we know that our y of m is supposed to be equal to y1 plus y2 over 2. So our y of m is negative 2 is equal to y1, which is b. Now y1 is 5. 5 plus b all over 2. So we have negative 4 b equal to 5 plus b. So we have our b to be equal to negative 9. Now our midpoints, or the values of b, the coordinates of b are 7, negative 9. Find the midpoint of the 2 points given. So a minus 4, then a plus 2, 6 plus a. So as usual, x of m will be equal to x1, which is a. So a plus 2 over 2, and this will give us 2a plus 2 over 2, and this will simplify to a plus 1. Then also our y sub m will be equal to a minus 4 over 2. Okay, a minus 4, that is y1, then plus y2, which is 6 plus a, so over 2, and this will give us 2a plus 2 over 2, which also simplifies to a plus 1. So midpoint m has coordinates a plus 1, comma a plus 1. Here's our third work example. ABCD is a parallelogram. Then A is the 0.25, B is the 0.88, and the diagonals intersect at 3, whole number 1 over 2, 2 whole number 1 over 2. What are the coordinates of C and D? So let us quickly sketch our parallelogram. So this is parallel to this, then this is parallel to this. Now the diagonals, so we have this, then this, be intersecting over here. So the coordinates are 3 whole number 1 over 2, then 2 whole number 1 over 2. Then we have our A here having coordinates 2, 5, then B here having coordinates 8, 8. Then we have C here, let's say has coordinates AB. Then we have D here having coordinate C, D. Now let's find the value of A, B, C, and D. So we know that C plus 8 over 2 will give us 3 whole number 1 over 2. So C plus 8 over 2 will be equal to 3 whole number 1 over 2. The reason is that the property, or one of the properties of a parallelogram, is that the diagonals bisect each other. So here is the midpoint of the line, or the diagonal BD. Here is the midpoint of it, and the same thing applies to AC. So we use the same, or we use the midpoint formula to find the value of C and D. So we just simplify this. We know that this will simplify to now C plus 8 over 2 will be equal to 7 over 2. Then this will give us, or this will imply that our C is equal to 7 minus 8, which will give us -1. Then also we know that our D plus 8 over 2 will be equal to 5 over 2, which is 2 whole number 1 over 2. And this implies that our D will be equal to -3. Then we also have A. A plus 2 over 2 should give us 7 over 2. So A plus 2 over 2 should give us 7 over 2. So we get our A to be equal to 5. Then also, we know that B plus 5 over 2 should be equal to 5 over 2. So we get our B to be equal to 0. And the coordinates of C are we have 5, comma 0. Then D, we have coordinates -1, -3. Work example 4. The coordinates of A and B are -9, 3 and -3, 9, -3, 4 respectively. B is the midpoint of AC and C is the midpoint of AD. What are the coordinates of C and D? Let's sketch the line quickly. So we have A, B, or AC. Then the coordinates of A are -9, 3. Then the midpoint is B, which is -3, 4. Then C, we don't know. So we have A, comma B. Now, we know that x of m, which is -3, will be equal to A plus -9 over 2. So we have -6 be equal to A minus 9. So A is therefore equal to 3. Then we know that B plus 3 all over 2 will be equal to 4. So we have B plus 3, B equal to 8. So we have B equal to 5. So we have the coordinates of C being 3 and 5. Now for D, we have -9, 3 as coordinates for A. Then D we don't know, so let the coordinate be CD. Then we have the midpoint to be C, which is 3, 5. So C minus 9 over 2 will be equal to 3. So we have C be equal to 6. Then we also have D plus 3 over 2 be equal to 5. So we have D be equal to 7. And the coordinates of D are 6 and 7. This is our next example. A 1, 5 and B, 7, negative 9 are 2 points. AB is divided into 4 equal parts at C, D, and E. Find the coordinates of C, D, and E. So we quickly sketch that one too. We have A here. Then we have our B here. So we have this here, this here, and this here. So here is our C, here is our D, and here is our E. So we know the coordinates of A to be 1, 5, and the coordinates of B to be 7, negative 9. So we can find the coordinates of D because D will be the midpoint of A and B. So this will give us 7 plus 1 over 2, that will give us 4. Then negative 9 plus 5, which will give us minus 4 over 2, so give us negative 2 here. Then now we can find the coordinates of E. Let's say this is A, B, then this one is C, D. So we know that C will be equal to 1 plus 4 over 2, and this will give us 5 over 2, or 2 whole number, 1 over 2. Then D will be equal to 5 minus 2 over 2, and this will give us 3 over 2, or 1 whole number, 1 over 2. Now let's find A and B. So A will be equal to 7 plus 4 over 2, and that will give us 11 over 2. Then also we have B equal to negative 2 plus negative 9 all over 2 to give us negative 11 over 2. So we have B equal to negative 5 whole number, 1 over 2, and this B equal to 5 whole number, 1 over 2. So we know the coordinates of C to be 2 whole number, 1 over 2, then 1 whole number, 1 over 2. And the coordinates of D are 5 whole number, 1 over 2, and minus 5 whole number, that is negative 5 whole number, 1 over 2.